So this is going to be a video showing an example problem using chain rule. Now, chain rule is used whenever you have a composite function and you're trying to find its derivative. So the composite function I have right here is this quantity x minus 1 squared. Okay, so it's a function, this x minus 1, inside of another function, which is this squared. So this would be the inside function, this would be outside. So you're basically having this x minus 1 and you're doing some other function to this entire function there. Now, the chain rule is written right over here in green. So basically you just take the derivative of that outside layer, but you keep the inside layer completely the same as it was. Then you multiply by that inside layer's derivative. In this case, it would be just g prime of x, because g prime was that inside layer of that composite function. So basically right here, I have an inside layer and then the outside layer. If you want to think inside and outside, the easiest way to think about that is what would you do last in order of operation. So if you knew what x was, you would subtract these first, because parentheses would be happening first, then you would be doing the exponent. So if you remember your order of operations, you always do parentheses first, then exponent. So we are going to focus on this outside layer first. So it's like you're peeling back an onion. You can call this the onion rule if you want. You're basically attacking that first outer layer of the onion first before you break down into the inner layers. So this inner layer is this squared right here. Now this squared represents a power function. In this case, it would just be like x squared, even though this isn't really x, it's x minus 1, but this would be considered a power. Okay, so what we're going to do is use the power rule to find the derivative of this outside layer. So f prime of x would be using the power rule first on this 2, so you would bring the 2 down. You would not touch that inside layer because you just take the derivative of the outside layer and keep the inside the same. So x minus 1 is the inside layer. I'm keeping that the same. And then I'm subtracting 1 from the power up here because of power rule. Okay, so it'd be 2 minus 1. So that would just end up being 1. And then I'm going to multiply it by the derivative of this inside layer. The inside layer of x minus 1 would just be 1. So it's kind of an easy derivative to figure out. So then from there, you would end up with 2 times x minus 1. And then you can distribute this out, and you end up with 2x minus 2 for your answer for this function right here. Now, the great thing with chain rule is that you can actually test this out really quick. So what I'm going to do is expand this x minus 1 quantity squared, and then I'm going to use power rule and see if I still get that 2x minus 1. So here we go. Okay, so if I expand out this f of x right here, I get x squared minus 2x plus 1. Okay, so now the derivative of this using power rule would be 2x minus 2, based on the power rule of this x squared and this negative 2x right here. If you can see, chain rule matches what you would get if you actually expanded all this out. Now you might be thinking, well, why don't I just expand out every single function that I get where I have to use chain rule? The great thing about chain rule is that this works for easy functions like this, but it also works for really complicated ones. Imagine if this said x minus 1 quantity to the 7th power instead of this squared right here, or to the 8th power. You wouldn't really be able to expand this out so easily like I did over here. So that's basically the power of chain rule. Yes, you can expand out simple ones like this, but if you get a really, really complicated composite function that you have to find the derivative of, it's actually pretty easy to do using chain rule compared to actually mathematically breaking it down like this and then using the power rule. So that's an example problem of using chain rule. If you have any questions about anything in this video, let me know.